College Route with Bongi. My name is Bongekile Ralarala, and today we are going to be doing Kirchhoff's law with three unknowns, which is basically three unknown currents. I got the problem or the circuit from our Electrotechnics N4 textbook, and it is question number 7, last question of exercise 1.5, which is Kirchhoff's and Norton's theorems. Without wasting time, let us get into it.
So here we have our Whetstone bridge, right, with this resistor R1, I1, and this is our 2 ohms, this is 5 ohms, this is 4 ohms, this is 3 ohms, this is, these are our currents, this is 1 ohm, and then these are our currents. This is I1 plus I2. I'm going to show you just now where this I1 plus I2 comes from. So basically, current that flows here is this current plus this current. So it is I2 plus I3 plus I1 minus I3. So when we write it down, we are going to do this. I'm going to remove it, so please pay attention so that you understand as we continue to do our calculations, right? So the current that flows here, let's say DA, IDA, let's call it that, is equal to this current, which is I2 plus I3 plus I1 minus I3. So when you remove the brackets, you are going to say I2 plus I3 plus I1 minus I3. So you see what's going on here. We have plus I3 and we have minus I3. So what we do is, these two, they will cancel out, and then we are going to be left with I1 plus I2 or I2 plus IT, either or, it's still the same thing. So our IDA becomes I1 plus I2. I hope you guys understand. I'm going to remove it because I'm going to need this space for my calculations. The first loop that we are going to start with is this one, which is A, B, D, A. So consider loop A, B, D, A. Right. So our voltage is 4 volts, which is equal to 1 I1. So 1 I1 is basically I1, and then 2 into I1 minus I3. So it's plus, because our current is going this way. So it's 2 into I1 minus I3. Plus again, because our current is going this way. So it is plus 1 into I1 plus I2. Right? So when you simplify all of this, we're going to put it like this. I1 plus 2I1 minus 2I3 plus I1 plus I2. Then it becomes I1 plus 2I1 is 3I1 plus I1, it is 4I1. Let's get I2, then it is plus I2, because we only have one I2, and then minus 2I3. That is our equation 1. For equation 2, we are going to consider our second loop, which is going to be this one. A, B, C, A. So consider loop A, B, C, A. As you can see, from our loop A, B, C, A, there is no voltage here. So our voltage is going to be 0, which is equal to then I1, remember, our R is 1, so we're just going to write I1 plus, because our current goes there, so it's 5I3. And then we come back here. Now because we are opposing the flow of current, we are going to say minus 4I2. So let's just put it in order, because it's fine like this, but I just want to put it in order so it makes sense. Minus 4I2 plus 5I3. That is our equation 2. Then our last equation, it is going to be this loop, which is loop BDCB. So consider loop BDCB. Again, there is no voltage, so here we are going to have 0, and then here we are going to have 2 into I1 minus I3. We are opposing again the flow of current, so it is going to be minus 3 into I2 plus I3. Again, we are opposing the flow of current, which means we are going to have minus 5 I3. Okay, let's just simplify it. 2I1 minus 2I3 minus 3I2 minus 3I3 minus 5I3. Let's add. 0 is equal to, we have only one I1, so it is going to be 2I1, and then I2, because we want to have them in order, it's minus 3I2. Then lastly, we have minus 2I3 minus 3I3, which is 5I3 minus 5I3, which then is minus 10I3, and that is our equation number 3. Then when we are done with that, what we're then going to do after all of this, we are going to eliminate I1 from equation 1 and equation 2, right? Now what you need to do when you have a question like this, you need to write your every move. So if you are eliminating I1, you must write from equation 1 and 2. Eliminate. You write everything I1, right? So that the marker knows what is it exactly that you did. So then, when we eliminate I1, what we are going to do is, we are going to multiply equation 2 by the coefficient of I1 from equation 1. So the coefficient of I1 is 4. So then we're going to multiply our equation 2 by 4. Again, you write everything down, right? So let us multiply our equation 2 by 4, which is going to give us, I hope you can see me from here. So equation 2 by 4, here's our equation 2. 0 times 4 is still 0. I1 times 4 is now 4I1. Minus 4 times 4, it is now minus 16I2. And then plus 5 times 4, which then gives us plus 20I3. Yes. Then from there, we name this our equation 4, right? Then what we then do again, we will multiply equation 1 by the coefficient of I1 from equation 2. So I1 is 1. So our equation 1 will be multiplied by 1. What does that mean? It means our values are not going to change. So 4 times 1 is still going to be 4, and then 4I1 plus I2 minus 2I3, right? It remains equation 3 because our values did not change, right? So what we do then is, so now that we have all our equations, what we then do is we eliminate I1. Now, in order to eliminate I1, we are going to, but you must remember to write all the moves that you make so that the marker understands what is it exactly that you did in order to get what you got. So here, what we do is, in order for us to eliminate I1 from equation 2 and equation 1, we are going to say from equation 2 and equation 1, eliminate I1. Then we go ahead and eliminate. What do we do when we eliminate? It's what we all know. We multiply our equation 2 by the coefficient of I1 from equation 1, right? So we are going to multiply, so 0 times 4 becomes 0, and I1 times 4 becomes 4I1, and I2 times 4, I minus 4I2 times 4 becomes minus 16I2, and then 5I3 times 4 becomes plus 20I3. That then becomes our equation number 4. Then what we do next is we multiply, or I said here you must write all your moves. So when you multiply equation 2 by the coefficient of equation 1, you must say equation 2 times the coefficient of I1, which is 4. And then here, now when we do the same on equation 1, multiplying it by the coefficient of I1 from equation 2, we must then write down equation 1 times 1, right? Now multiply equation by 1, we're going to get 4. Our values are not going to change, so we're just going to write them as they are, minus 2I3. This then remains our equation 1 because the values did not change, okay? So this remains our equation 1. Now our next step, it is to, remember we are eliminating I1, so our next step, it is to subtract equation 1 from equation 4, right? So we write that down. Equation 4 minus equation 1. Then we go ahead and subtract. So what we do is we say 0 is equal to 4I1 minus 16I2 plus 20I3 minus 4I1 minus it's plus I2 minus 2I3. 0 minus 4 remains minus 4 is equal to, this becomes 0. Now minus 16 minus I2 becomes minus 17I2. Then 20I3 minus 2I3, it then becomes plus 22I3. What we then do is, I want us to make I to the subject of the formula, and then just to save us some space, and because we can leave it like this and say this is our equation 5, but I don't want us to do that. I want us to make I to the subject of the formula and name it our equation 5. Alright, so let's go ahead and do it. It's minus 4 minus 22I3 is equal to minus 17I2. We divide by minus 17 on both sides, cancel, then our I2 becomes minus 4. We don't want to leave it in fraction form, just to make it simple for us, let us leave it in decimals. So gives us 0,235, and then minus 22 divided by minus 17 gives us plus 1,294I3. That is then our equation 5. So what we do next is we say from equation 2 and now equation 3, we eliminate I1. We write that down. Remember to write your moves down. From equation 2 and 3, eliminate I1 again. If you eliminate I1 first, you must eliminate I1 from all your equations. So we do the same thing here. What do? We multiply equation 2 by the coefficient of I1 from equation 3. What is it? So we say, what is the coefficient? It's 2, right? So we'll say 0 times 2, it remains 0. And we're going to say I1 times 2, it's 2I1. And minus 4 times 2, it's minus 8I2. 2. Plus 5 times 2 is plus 10i3. This then becomes our equation 6. Then again, remember to write your moves down. What you are doing here is you are saying equation 2 times 2, which is from equation 3. And then here we are going to now say equation, oh, this was equation 3. Sorry, this was equation 3. No, this was equation 2 times 2, which was from equation 3, so this is equation 3. Now we are going to multiply equation 3 by the coefficient of I1 from equation 2. So we are going to say equation 3 multiplied by 1, which is our coefficient of I1. What will happen? Our values will remain the same. What does that mean? We write them down as they are, and it remains our equation 3. Let us quickly write them down. Here's equation 3. It's 0 is equal to 2i1 minus 3i2 minus 10i3. It remains our equation 3. Now, remember, the plan is to eliminate I1. What do we do when we eliminate I1? We are going to subtract from our two equations, equation 6 and equation 3, we are going to subtract. Now, we are going to subtract because our values have the same, signs, positive and same polarity, which is positive 2, positive 2. So we are going to subtract. Now, let us write the equations down. We are going to subtract equation 3 from equation 6. So equation 6 minus equation 3, right? Let's write equation 6 down. Our equation 6 is 0 is equal to 2i1 minus 8i2 plus 10i3. 0 is equal to 2i1 minus 8i2 plus 10i3 minus, what is our equation 3? 0, 2i1 minus 3i2, 2i1 minus 3i2, and minus 10i3, minus 10i3. We subtract 0 minus 0 is 0, and this becomes 0. Then minus 8 minus minus 3. It gives us minus 5i2. And 10 minus minus 10, it gives us plus 20i3. Right? We leave it as it is. I don't want us to write it down again. Just to save us some space, we're going to leave it there, and we are going to call this our equation 7. What we then do is, remember that I2, which we made subject of the formula right here, we are going to substitute that I2 from this equation, right? So let's substitute. It's 0 is equal to minus 5 into what is our I2? 0,235 plus 1,294i3 plus 1,294i3 plus 20i3. 0 is equal to, is minus 1,175 minus 6,47 I3 plus 20i3. Now, let us do this and say this is going to be equals to minus 1,175. So minus 6,47 plus 20 plus 13,53i3. Then this comes to this side, which now becomes 1,175 is equal to 13,53. Remember, we are going to get I3, so we divide by 13,53, divide by 13,53. This our I3 then becomes as 0,088 it's giving us 0.0868. So we're just going to round it off to 3 decimal places, which is then going to be 0.087 amps. Remember to write your SI units because you get marks for that. Now we take this I3 and substitute it from our, remember that I2 that we made substitute of the formula? Let's now substitute this I3 from that equation. So what we do, remember, we write our moves down. So we say substitute I3 in equation, what was our equation? It was equation 5. In equation 5, write it down. I2 is equal to, let's just substitute right away, 0.235 plus 1 plus 1.294 into I3. So we substitute 0.087 in I3 and then we get our I2. It's 0.3475, but we're going to round it off to 2 decimal places, which is 0.348 amps. So from equation 1, substitute I3 and I2 in order to get I1. Here's our equation. It is 4. Let's substitute right away. Here's our equation, you remember. So let us substitute right away and say 4I1 plus I2. What is our I2? Our I2 is, what is our I2? 0.348, 0.348 minus 2I3, so it's minus 2 into, what is our I3? 0.087, right? Let us write our values down. Is equal to, so we take 0.174 to this side, which is going to be 4 minus 0.174 for I1 divided by 4 divided by 4. Then we are going to get our I1. Our I1 is 0.957 amps, right? Remember, from our questions we were given the currents to look for. They said here we must look for our current AB. Our current AB is I1. We have gotten our I1. We have gotten our I1, so this is our current AB, right? This is our current AB. And then they said let us also look for AC. AC is our current I2. We have gotten our current I2. Where is our current I2? This is our current I2, which is AC. And then they said again, let us look for BC. BC is our current I3, which we have also gotten, BC. And then they said again, we must look for current BD. BD is I1 minus I3. So we are supposed to say IBD is equal to I1 minus I3. Then we substitute. What is our I1? 0.957 minus I3 0.087. Put it in the calculator. 0.8787 amps. And then we are also instructed to look for CD. CD, it is I2 plus I3. So we are going to write it down here and say, I want to use this marker because it writes better. CD, excuse me, ICD is equal to I2 plus I3, which is then equal to, we substitute, I2 is, where is I2? 0.348 plus I3, which is 0.087 equals to 0.087 plus 0.348. It is equal to 0.435 amps. Then lastly, we're instructed to look for DA. DA is this current. Remember we said DA is I1 plus I2, so IDA is equal to I1 plus I2. Substitute. I1 is, where is our I1? It's our I1. 0,957 plus I2, 0, this is plus guys, 0,348, 1,305 amps. Now you should take your book and compare all the answers that I have gotten here to the answers that they have gotten from the textbook. That is it for today. Thank you so much for watching. I will see you on my next video. Take care.